Okay, let's unpack this. Imagine for a moment, just try and picture it. Living in a world with absolutely no writing.
It's tough to even conceive of, isn't it?
Right. No books, no emails, obviously, but no street signs, no contracts, nothing written down.
How would you pass down history reliably or enforce laws across, any kind of distance?
Or even just manage trade, keep track of who owes what. It seems impossible.
Yeah. Writing is just so fundamental to everything. How we think, organize, remember.
So today we're doing a deep dive that takes us right back to one of the very first places where this, well, world-changing technology popped up.
We're talking cuneiform, that amazing wedge-shaped script from ancient Mesopotamia.
Exactly. And this deep dive, it's built straight from the sources you've given us, articles, research notes. Our mission, really, is to pull out the key stuff, the big ideas, to get our heads around what cuneiform was, and maybe more importantly, why it mattered so much, and why it still echoes today.
Yeah, to really get cuneiform, you have to picture the place, Mesopotamia.
For the land between the rivers.
Right, the Tigris and the Euphrates. Yeah. Modern-day Iraq, basically, often called the cradle of civilization, and for very good reason.
Because of the farming, the fertile land.
Precisely. Those rivers, early irrigation. It let people settle down, grow more food than they needed, surpluses.
Which leads to villages, then towns, then, boom, the first cities.
Exactly. And that's where we're starting our journey, time-wise. Late 4th millennium BC. Say around 3500 BC onwards.
Okay.
Because it's right then, with the pressures of managing these growing cities, the surplus food, the trade, that's when the need for a new way to record things became, well, urgent.
So it wasn't like someone just invented writing in a flash of inspiration.
Not at all. That's what's so cool about it. It wasn't like invented overnight as a perfect system. It emerged bit by bit.
Driven by practical needs.
Totally practical needs. And how it developed, step by step, got completely tangled up with how civilization itself was getting more complex. They grew together.
Okay, so let's go right back to the very, very beginning. Before the wedges, before even symbols for words, what was the first step?
Well, before writing symbols, they were using actual objects. The sources talk about this system of clay tokens in Neolithic Mesopotamia.
Tokens, like game pieces.
Sort of, yeah, but very specific ones. Carefully shaped little clay bits, cones, spheres, discs, cylinders. And each shape, it seems, stood for a particular amount of a specific thing.
Ah, okay, so a little cone might be, I don't know, 1 measure of barley.
Exactly. And maybe a sphere was a bigger measure, or a cylinder meant 1 sheep or something like that.
A kind of 3D accounting system.
That's a great way to put it, a very early physical accounting system. If you're sending off goods, say, 5 units of grain, 3 jars of oil, you'd gather the right tokens.
Okay, but how do you make sure that record stays accurate, that it doesn't get lost or changed?
Good question. The system evolved. The sources describe how they started putting these tokens inside a hollow ball of clay, like an envelope. It was called a bulla.
Clay envelope.
Yeah, they'd put the tokens inside to seal it up. So you had a tamper-proof container holding the record of the transaction.
But wait, if it's sealed, how do you know what's inside without smashing it?
Brilliant solution. Before sealing the bulla, they'd press the tokens that were going inside onto the outside surface of the clay ball.
Oh, I see. So the outside showed impressions of the tokens that were sealed inside.
Exactly. You got a sealed record plus a visual summary right there on the envelope. And that act of pressing, making an impression, that was a huge step.
Because it separated the record from the actual physical token?
Precisely. It's the beginning of representing the token rather than just using the token itself.
And that leads where? Did they realize they didn't need the tokens inside anymore?
It seems so. The next logical step. If the impressions on the outside tell the whole story, why bother with the tokens inside the hollow ball?
Right, you just need the impressions.
So we see the shift, away from tokens inside clay balls towards making impressions directly onto solid pieces of clay, flat tablets or sometimes slightly curved, kind of pillow-shaped ones.
Still using clay, though.
Oh yeah, clay was everywhere.
Yeah.
Readily available. So now, instead of the hollow bulla, just a solid slab.
And what were they using to make the impressions now? Still the tokens?
Initially, maybe sometimes, but the tools started changing too. The sources mention a reed stylus, often with a round end.
Okay.
They'd press this round end into the soft clay. Different sizes of styluses, or maybe pressing harder or softer, or at different angles, that let them make marks that stood for numbers.
So like a big circle impression for 10, a smaller one for 1, something like that.
Yeah, along those lines. The early system was very much focused on numbers, on quantities.
But just numbers. That's not quite writing, is it? You need to know what you're counting. 5 big circles doesn't tell you much on its own.
Exactly. And that's the next crucial leap. They started adding pictures, pictographs.
Drawings.
Simple drawings, yeah. Incised into the clay with a sharp point, maybe the other end of the stylus. Next to the number marks, they'd sketch a little picture of what was being counted.
Like a little drawing of a sheep head next to the number for 3.
Precisely. Or a stalk of grain, a jar, a fish, whatever it was.
Yeah.
That combination number marks plus a picture that's the real bridge towards writing as we think of it.
Let's stick with that barley example from the sources. It seems really key. Barley was super important, right? Food, beer, payments.
Absolutely fundamental to the Mesopotamian economy. So the earliest written sign for barley wasn't based on how the word sounded.
It was just a picture of barley.
Right. A simplified drawing, something that looked like a stalk or head of barley.
Yeah.
Easy enough to recognize visually.
But, and this is the important bit you mentioned, that picture didn't tell you the sound. In Sumerian, the word was she, but the picture didn't represent sh or a.
Exactly. It represented the thing barley. Someone who didn't speak Sumerian might guess the picture meant barley, but they wouldn't know to say she.
Okay, and that highlights the problem with only using pictures, right? Pictographs have limits.
Big limits. They're okay for simple, concrete nouns, man, water, sheep. But what's about abstract ideas?
Like love or sadness or belief. How do you draw those?
Very difficult, if not impossible. And what about grammar? Past tense, plurals, prepositions like under or because.
Or names. How do you write someone's name with just pictures?
You really can't, reliably. Pure pictographs just struggle with anything beyond the most basic nouns and quantities. And crucially, they don't capture pronunciation. That's a huge limitation if you want to represent spoken language accurately.
So the system had to change. It needed to handle more complex stuff, and it needed to represent sounds, which leads us to the wedges.
The wedges, yes, the next really big shift. This happens around the 29th century BC, give or take. It involves a change in the tool and the technique.
No more drawing lines or pressing round ends.
They moved to using a reed stylus, but one with a specifically shaped tip, triangular or angled.
Okay.
And instead of drawing, the scribes would press this angled tip into the soft clay. And that motion, pressing the corner of the stylus in, created a distinctive wedge shape.
Cuneus, Latin for wedge, hence cuneiform.
That's it. And this technique, pressing wedges, was apparently faster and cleaner on clay than trying to draw smooth curves or complex pictures. This is the start of what we call archaic cuneiform.
So these wedges become the new building blocks. How many basic shapes were there?
The sources break it down to 5 fundamental wedge strokes based on how you press the stylus. There's a horizontal one called I, a vertical one, a downward diagonal, GE23, or sometimes called D10, meaning tilted D, an upper diagonal, GE22, and then one called the Winkelhaken U, which is like a little angle bracket or corner shape.
Just 5 basic marks, but they made thousands of signs out of those.
Exactly. By combining these 5 basic wedge types, changing their orientation, their size, how many they used, they could create an incredible variety of distinct signs.
And the sources mention something about tails.
Right. Except for the Winkelhaken, the other 4 basic wedges could have a tail, the line, extending from the wedge head. Scribes could vary the length of this tail, adding another subtle variable to the sign's appearance.
It sounds like it's getting quite abstract now, moving away from pictures.
Very much so. And the signs themselves weren't static either. The sources talk about ways they could be modified. A sign could be tenu, which means tilted, usually about 45 degrees.
Okay.
Or you could have gunu, or gunification, which meant adding extra wedges to an existing sign, maybe to change its meaning or sound slightly.
More complexity.
Definitely. Then there's hasheg, which involved adding a kind of cross-hatching pattern made of Winkelhakens inside a sign. And utilu meant removing wedges from a sign.
Wow. Tilting, adding, cross-hatching, removing, lots of ways to tweak them.
Yeah, and you can see how quickly this moves the script away from looking like pictures. It becomes about learning these conventional patterns of wedges. The sources say a typical sign might have, say, 5 to 10 wedges.
But some were way more complex.
Oh, yes. Especially signs formed by combining others, called ligatures. The example given is KXGUR7, which apparently used 31 individual wedge strokes.
31. Just making that one sign sounds like a workout.
Requires serious skill and care, absolutely. It's less about sketching an image and much more about executing precise, learned sequences of strokes.
And this abstraction, this move to conventional patterns, was that linked to representing sounds?
It seems so. That move away from pure pictography was essential for cuneiform's next big step. incorporating phonetic elements. Signs started representing not just whole words or concepts, but also the syllables of the spoken Sumerian language.
Ah, so now they can start writing things based on sound.
Yes, which gives the script much more flexibility. Now you can spell out names, represent grammatical endings, capture spoken language much more closely than you could with just pictures or word signs.
And this is where the Akkadians come in.
Right, a huge moment in history. Around the 23rd century BC, the Akkadian Empire rises, conquers the Sumerian city-states. The Akkadians see the power of this writing system and they want to use it.
But they spoke a totally different language. Akkadian, Semitic, not Sumerian.
Completely different structure, different vocabulary. Sumerian is what we call a language isolate, no known relatives. Akkadian is related to Hebrew, Arabic. So how do you write Akkadian using Sumerian script?
Big challenge. What did they do?
Well, the sources say they basically did two main things. First, they took the Sumerian signs that already stood for syllables like ba, ka, tu, and just used them to write those same sounds when they appeared in Akkadian words.
Okay, borrowing the phonetic values.
Exactly. But second, they also kept using many of the original Sumerian signs for their logographic value, meaning as a sign for a whole word, but they pronounced that word in Akkadian.
Right, the sheep example. The sign looks like a sheep. A Sumerian reads it and says udu. An Akkadian reads the same sign and says imerim, their word for sheep.
The perfect example. Those borrowed Sumerian word signs used in Akkadian texts are called sumerograms. It adds another layer, because a reader has to know whether to read a sign phonetically as a syllable or as a sumerogram representing an Akkadian word.
So the script becomes this mix of word signs, logograms, including sumerograms, and sound signs, syllabograms.
Exactly, a logographic syllabic script. Incredibly flexible, it could adapt to different languages, but wow, did it get complicated.
How complicated.
Well, think about ambiguity. A single cuneiform sign could often represent multiple different things. It might be a logogram for a specific word. It might be a syllabogram for a particular sound.
And sometimes the same sign could be the logogram for several different words, or represent several different syllables.
Yes. The sources give the example of the Sumerian syllable sound go. Apparently, there were 14 different cuneiform signs you could use to write that one sound.
14 ways to rate go. How did anyone keep track?
Good question. And the other way around, too, one sign could have many possible readings. A scribe writing it had to trust the context made it clear, and a scribe reading it had to be really skilled to figure out the intended meaning or sound.
So did they develop ways to make it clearer, to reduce the confusion?
They absolutely had to. The sources talk about combining signs in clever ways. One method was compound signs, just sticking existing signs together.
Like building blocks.
Right. Sometimes the meaning was pretty logical. They give the example Ka, the sign for mouth, combined with A, the sign for water. Put them together, Ka, and it meant drink. Makes sense.
Mouth plus water, drink. Okay, I get that.
But other compounds were less about combining meanings and more about hinting. The sources mention Ka, mouth, plus N, prince. Combined as Kn, it didn't mean prince's mouth. It meant lip, and it was red nundum.
Okay, that's less obvious.
Yeah.
How does mouth plus prince equal lip?
It's based on convention, maybe some deeper semantic or phonetic link that's not immediately clear. The sources compare it to how some Chinese characters are formed, with one part hinting at meaning and another hinting at sound. So here, maybe Ka suggests the mouth area, and Nun helps indicate the specific word nundum, lip.
That requires a lot of learning, memorizing these combinations.
Definitely. And then there was an even trickier type. Diri compounds. These are sequences of signs where the combined reading is totally different from the individual sign's usual meanings.
Uh-oh.
The example given is IGIA, that's the sign IGI, I, followed by the sign A, water. But read together as a Diri compound, it means imher, foam.
I plus water equals foam, and reads imher. How does that even work?
Again, it's convention. These are specific learned combinations where the whole is different from the sum of its parts. Maybe there is an old reason, but for the scribe it was just IGI plus A when read this way means imher.
Wow. Okay, so the potential for confusion must have been huge, especially with the signs that had multiple very different meanings.
For sure. And the sources give a fantastic, detailed example of how scribes used extra clues, phonetic complements, and determinatives to pin down the meaning of a really ambiguous sign.
Let's walk through that one. It was the sign NEA, right, which Assyriologists write as UGA in capital letters.
That's the one. So this single sign, negogia, could mean raven, pronounced UGA, or it could mean soap, pronounced negoja.
Raven or soap. That's quite different.
And that's not all. It could also stand for the name of a city. Ire, or even the name of a goddess, Nizaba, who happened to be the goddess of grain and writing.
Okay, that's crazy. One sign means raven, soap, a city, or a goddess. How on earth do they specify which one?
Right, you need disambiguation. So if a scribe wanted to write raven, which is pronounced UGA.
They needed to hint at that UGA sound.
Exactly, so they'd add phonetic complements. These are extra little signs placed near the main sign, purely to indicate pronunciation. To confirm the UGA sound of naga, they might put the sign U, which sounds like oo, before it, and the sign GA, which sounds like after it.
So you'd write ooh, nagi, GA.
Ooh, dat nag GA, yes.
Yeah.
The oo and GA act like pronunciation guides, pointing you towards the UGA reading of that middle naga sign.
Okay, that helps with the sound, but it could still be a name with uga in it, maybe. And you make sure it means the bird.
Good point. For that, they use determinatives. These are signs that signal the category of the word, but they aren't pronounced themselves.
Like a little category tag.
Exactly. For raven, they'd add the determinative sign mushin at the end. Mushin was the sign that meant bird. It told the reader, the word ending here belongs to the category of birds.
So the full unambiguous spelling for raven became u.nego.ga, then the mushin sign.
Unega jomush.
Uh-huh.
Often the determinative like mushin would be written a bit smaller or raised.
Mhm.
But yeah, you have the core logogram, an agie, phonetic clues, UGA, and a category marker. Mush all working together.
That is intricate. It really shows how the system had to evolve these complex layers to handle ambiguity as it got used for more things.
Absolutely. And it was this flexibility, this ability to adapt even with all the complexity that let cuneiform spread beyond Mesopotamia.
It wasn't just Sumerian and Akkadian.
Oh no. From Akkadian, it got adapted to write languages from completely different families all over the ancient Near East. Elamite over in what's now Iran, Hittite up in Anatolia, modern Turkey, Hurrian, Urartian.
So all these different cultures looked at cuneiform and thought, yeah, we can make this work for our language.
Pretty much. They'd borrow signs, adapt values, maybe invent a few new ones, figure out how to represent the sounds and grammar of their own language using this wedge-based system.
And the sources also mention scripts that were sort of inspired by cuneiform, but different. Old Persian and Ugaritic.
Right. They used the wedge shapes, probably because the tools in the medium, clay, were common, but they simplified the system dramatically. Old Persian cuneiform, used by kings like Darius, was mostly syllabic, much closer to an alphabet.
Simpler to learn, presumably.
Much simpler. And Ugaritic, from the Syrian coast around the 13th century BC, went even further. It was a true alphabet, using wedge shapes, but where each sign stood for a single consonant sound, a major innovation.
So cuneiform itself eventually led towards alphabets in some places, but the original complex Sumero-Akkadian version stuck around for a long time.
A remarkably long time. The sources confirm it was going strong throughout the second millennium BC. Hammurabi's Code, around 1750 BC. Cuneiform. It was the script of empire, religion, science, literature.
But it did eventually fade out. Why?
Well, the sources suggest its use for everyday government stuff started declining during the Persian Achaemenid Empire, starting 6th century BC. Aramaic, written with a simpler alphabet on easier-to-handle materials like papyrus or parchment, became more practical for administration across a vast empire.
So cuneiform became more specialized.
Exactly. It hung on for centuries longer, mainly in religious temples and scholarly circles. Scribes kept copying ancient texts, astronomical records. It became a script of tradition and deep learning. But eventually, even that faded.
When did the last wedges fall silent?
The sources point to around the 1st century CE. That's when the last known dated cuneiform texts were written, the end of a 3,000-year run. The last wedge is kind of a poetic way to think about that final disappearance.
3,000 years. Just incredible longevity. Okay, before we jump to rediscovery and modern times, let's rewind a bit to the basics. The materials, we know it was clay, but what were the tablets actually like?
Right, the primary medium in Mesopotamia was clay, readily available from the riverbanks. Scribes worked with damp, soft clay, shaping it usually into hand-sized tablets. The sources often describe them as pillow-shaped, maybe flat on one side, slightly curved on the other, easy to hold.
And they'd use their stylus to press the wedges in. Then what? Just leave them.
For temporary records, maybe just sun-dried. But for anything important, anything meant to last, legal documents, royal inscriptions, literature, they'd bake the clay tablets in a kiln.
Like firing pottery.
Exactly. That made them hard, durable, which is why so many have survived for thousands of years buried in the ground.
Did they only use small tablets?
Mostly. But for really important texts, the sources mention larger formats too. Things like hollow clay cylinders or prisms with multiple sides, also made of terracotta. These could hold long texts like chronicles or building inscriptions, sometimes written incredibly finely.
And sometimes glazed.
Yeah, glazing could add durability and maybe decoration. Some of these objects are quite impressive.
How does this compare to Egypt? They weren't using clay, right?
Primarily, no. The sources contrast Mesopotamian clay with Egyptian materials, especially papyrus.
Made from reeds.
Right, papyrus reeds from the Nile, used from way back, maybe even as early as clay tablets started. Papyrus was light, flexible. You could make scrolls, basically rolls of any length, by gluing sheets together.
Was it easier to use than clay?
Probably lighter and more portable. And the sources suggest it might have been cheaper or easier to produce in bulk in Egypt than preparing clay tablets. Papyrus was a major Egyptian export, used all around the Mediterranean.
Does that difference in material tell us anything else, like about who was writing?
The sources speculate, yeah. Maybe the relative ease and lower cost of papyrus in Egypt helped writing become a bit more widespread there compared to Mesopotamia, where handling clay might have kept literacy more concentrated in a specialized scribe class. It's hard to know for sure, but it's an interesting thought.
Okay, materials covered. Now numbers. This is where my brain might start to hurt. Base 60.
Hey, yeah, the sexagesimal system. It's different, but really powerful. The Sumerians and later Babylonians used it for math and astronomy. We still see traces of it, right?
Like 60 seconds in a minute, 60 minutes in an hour.
Exactly. And 360 degrees in a circle, that's 6 times 60.
Yeah.
That all comes from them.
So how did they write numbers in cuneiform using base 60?
Amazingly, they mostly use just two basic symbols for numbers within each place. The sources say a vertical wedge, that D sign, meant 1, and the Winkelhaken in that corner wedge meant 10.
Just ones and tens? How do you get to 60? Or higher?
The genius part was positional notation. Just like in our system where the 1 and 10 means something different from the 1 and 1, position matters.
Okay.
In their base 60 system, the position of a symbol told you which power of 60 it represented. The rightmost position was units. The next position to the left was the 60s place. The next was 60 by 60, the 3600s, and so on.
Whoa, okay, so give me an example. How did they write, say, the number 70?
The sources show it written as
So the symbol for 1 and the symbol for 10. How is that 70?
because of the positions. The first symbol is in the 60s place, so it means 1 times 60.
Which is 60.
Right. The second symbol is in the units place, so it means 10 times 1.
Which is 10.
Add them up.
Yeah.
60 plus 10 equals 70.
Mind blown. Okay, so the order is absolutely critical. How would they write 11 then?
They'd write, oh,
Switch the order. The 10 symbol first, then the 1 symbol.
exactly. Now the O is in the tens place within the units position, so 10. And the O is in the ones place within the units position, so 1, 10 plus 1 equals 11.
So you really had to pay attention to the sequence and spacing. Did they have a 0?
Not initially. That was a later development. Often they just left a gap to indicate an empty place value, which could be ambiguous sometimes. But the system itself, base 60 positional notation, was incredibly advanced for its time and really good for calculations, especially with fractions. It fueled their sophisticated mathematics and astronomy, all recorded on cuneiform tablets.
Okay, so we've got the script's evolution, the materials, the math. Let's pull back again to the big picture, the guiding question. How did all this affect Mesopotamian civilization?
Right. We said it started from necessity, keeping track of farming and trade. Simple records.
But as society got bigger and more complex cities, kingdoms, empires...
Writing became more than just useful. The sources argue it became essential. It wasn't just recording what was happening, it was actively enabling that complexity. It allowed organization on a scale that simply wasn't possible before.
Like that trading card analogy from the source. A small collection? Fine. A massive one. You need lists. You need writing.
Exactly. Writing was the tool that let them manage civilization at scale.
So what kinds of things really couldn't happen, or couldn't happen as well, without writing?
Think about it. Ruling a large territory, you need written decrees, communication with governors, tax records, training an army, manuals, supply lists, orders, running large temples, ritual texts, calendars, offering lists, building huge structures like ziggurats, plans, calculations, worker lists, long-distance trade, contracts, letters of credit, inventories.
Okay, yeah, it touches everything.
Writing didn't just make these things easier, it fundamentally enhanced the ability to do them reliably, consistently, and on a much larger scale.
The sources really emphasize law and government.
Yes, that's a huge area. We see the first private legal documents, sales, loans appearing very early on, early 3rd millennium BC. People immediately saw the value for personal business.
And then big law codes.
Right. Mesopotamia gives us the world's first written law codes, starting around 2100 BC. Hammurabi's Code, 1750 BC, is the most famous, carved on stone for everyone to see, theoretically.
What did writing down laws actually achieve?
It standardized them. It made them permanent, less dependent on memory or a ruler's mood. It provided a reference point for justice. It was a massive step in formalizing governance.
And the sources connect this to the growth of the state itself, bureaucracy.
Absolutely. Writing is the lifeblood of bureaucracy. Think about organized taxation, regulations, keeping track of citizens, early census-like activities, managing state projects. All of this requires extensive record-keeping and written communication. Writing enabled the state to grow much more powerful and organized.
But it wasn't only about state power, was it? The sources mentioned empowering citizens, too.
That's a crucial counterpoint. While writing helped rulers rule, it also, over time, increased the ability of ordinary people, or at least literate people or those they associated with, to get informed.
How so?
Well, access to written laws, even if read aloud. The ability to form groups based on shared written ideas or information. A sense of shared history or identity fostered by written myths and chronicles. The sources even draw a line from this potential to the later history of journalism writing, giving visibility to more people and viewpoints.
So it's a double-edged sword, empowering the state, but also potentially empowering the people.
In a way, yes. It's a tool, and its impact depends on how it's used and who has access to it. Which brings us to the people who wielded this tool, the scribes.
They must have been incredibly important.
Hugely important. In Mesopotamia and also Egypt, scribes weren't just clerks. Yes, they started with economic records, but their role expanded massively. They became the experts, the keepers of knowledge.
What kind of knowledge?
Everything written. Astronomy, math, medicine, divination, predicting the future, history, religious texts, literature like epics and poetry, wisdom sayings. If it was written, scribes were the ones writing, reading, copying, and preserving it.
So literacy wasn't common. It was mostly these scribes.
Largely, yes. Literacy seems to have been concentrated among an educated elite. Being a scribe was a respected profession, often passed down in families. It required years of difficult training.
Where did they train?
The sources mention scribal schools, sometimes called edoba or tablet houses in Sumerian. These places weren't just schools. They often doubled as libraries or archives, storing vast collections of tablets.
So they learned by copying existing texts.
That was the big part of it, yes. Copying exercises, learning the thousands of signs, the logograms, the syllabic values, the grammar, the math. It was intense.
And this concentration of knowledge in written form, managed by scribes, what was the wider impact?
The sources argue it changed how knowledge itself worked. Writing allowed text to be shared more widely, compared across regions, criticized, built upon over time. Knowledge became more communal, more cumulative, less dependent on individual memory.
And religious texts becoming written down, that was huge.
Absolutely. For what the sources call scriptural religions, having a core written text became central to their identity, practice, and transmission.
The sources then broadened out, looking at writing's role elsewhere. India.
Yeah, they mention how in India the Brahmin caste used writing to codify huge amounts of knowledge that had previously been oral tradition. This formed the basis for education, philosophy, and also sciences like linguistics, Patini's incredibly detailed grammar of Sanskrit, for example, math, astronomy, medicine too, all written down.
What about the Americas? Maya, Aztecs.
They developed their own amazing writing systems independently. Scribes were revered figures, elite children went to special schools, they recorded astronomy, calendars, history, myth, genealogy, vast amounts of knowledge.
But so much was lost.
Tragically, yes. The Spanish conquest led to the deliberate destruction of countless Mayan and Aztec books or codices.
Yeah.
Huge loss for world history.
And China. Writing seemed central there for a very long time.
Immensely central. The sources highlight how knowledge of classical texts, philology, became the basis for the entire government bureaucracy through the imperial examination system. For literally millennia.
So knowing the classics got you a government job?
Essentially, yes. It created a powerful link between literacy, classical education, and state power. Chinese written culture covered philosophy, religion, law, science, medicine, military strategy, everything. And early printing there served the needs of this bureaucracy and monasteries before spreading more widely.
Okay, let's swing back west. Greece and Rome.
Writing was fundamental there too. Think Plato, Aristotle. Their philosophical dialogues and treatises exist because they were written, allowing analysis and debate across centuries, even if Socrates himself was skeptical about writing versus live dialogue.
And scholars writing big summaries of knowledge.
Exactly. The sources mention historians like Herodotus and Thucydides, medical writers like Hippocrates and Galen, mathematicians like Euclid, astronomers like Ptolemy, architects like Vitruvius. They compiled knowledge in written form, creating foundational texts for Western thought.
Then came the Islamic Golden Age. What was writing's role there?
A crucial one. The sources describe the Middle East, particularly Baghdad, with its House of Wisdom, as a major center for translating and preserving knowledge. Scholars translated Greek, Indian, Persian works into Arabic.
Saving texts that were lost in Europe.
Yes, in many cases. And they didn't just preserve, they made huge advancements, especially in areas like algebra. The word itself is Arabic, mathematics, medicine, optics, linguistics, and this knowledge spread through trade routes down into Africa, like to the libraries of Timbuktu, and eventually back into Europe.
How did it get back into Europe?
Often through places like Islamic Spain, Andalusia. Centers like Cordoba had incredible libraries. Scholars traveling there encountered these Arabic translations of classical texts and translated them into Latin.
And this kick-started learning in Europe again.
It played a massive role in the rise of the first European universities starting around the 12th century. These early universities were largely focused on studying these rediscovered classical texts.
But knowledge was still pretty locked up in manuscripts, right? Copied by hand, expensive.
Exactly. Which brings us to the next game changer, Gutenberg's printing press, around 1450.
And the sources say this just changed everything.
Fundamentally, suddenly books weren't rare, unique, costly items. They could be mass-produced, relatively speaking.
Yeah.
Much cheaper, much faster distribution.
Where did knowledge production happen then? Still monasteries.
It shifted. The sources point to publishing houses becoming new centers of knowledge creation and dissemination, alongside universities. Printing allowed scholars across Europe to have identical copies of texts.
Which meant they could compare notes easily, criticize texts.
Precisely, and crucially for science, they could print and rapidly share the results of experiments, observations, calculations. Everyone could see the same data, build on it, challenge it. The sources argued this was absolutely essential for the scientific revolution and the rise of scientific journals.
It's amazing to trace that line from wedges in clay to printed scientific papers.
It really is. The medium changes, the speed changes, but the fundamental power of writing to record, share, and build knowledge persists.
Which brings us back to cuneiform itself, but in the modern world, it's not used anymore, but we have the tablets. Lots of them.
An incredible number. The sources estimate something like 300,000 cuneiform tablets have been dug up and are now in museums and collections around the world. Maybe even more.
300,000? What's on them? Is it all just government records?
Oh, not at all. That's what's so amazing. Yes, there are administrative texts, contracts, receipts, but there's also mythology. Epic poems. The Epic of Gilgamesh is the most famous.
Right, the flood story.
Exactly. There are historical chronicles, royal inscriptions, law codes beyond Hammurabi, dictionaries, grammars, they studied Sumerian, math problems and tables, astronomical observations, medical texts, letters between people, religious rituals, omens, proverbs, even things like recipes for beer.
Beer recipes,
Seriously, it's this incredibly rich slice of life from the dawn of civilization. These tablets are often the earliest known examples of these kinds of writing. The first literature, the first laws, the first science. It's all there in cuneiform.
Okay, but here's the kicker from the sources that just blew my mind. How much of this has actually been read?
Yeah, this is the staggering part. The estimate is that only about 10% of all the known cuneiform texts have been translated or even properly read by experts in modern times.
10%? That means 90% of this stuff is just sitting there, unread. Like a library where 9 out of 10 books haven't been opened.
Pretty much, yes. It's a vast archive of human history, and most of it is still silent.
Why? What are the roadblocks? It seems crazy we haven't read more.
Several big reasons, according to the sources. First, the script itself is just plain hard. As we discussed, all those signs, the multiple readings, needing to know Sumerian, Akkadian, maybe other languages, it takes immense skill.
Okay, complexity is one.
Second, there just aren't enough people who can read it. The sources say there are maybe only a few hundred fully qualified cuneiformists in the entire world. It's a very small, specialized field.
Not enough experts. What else?
Access can be tough. The tablets are scattered across museums globally. Some might be uncatalogued, in storage, needing conservation. Getting access to study them isn't always easy. And finally, developing good learning tools, dictionaries, digital resources, that's an ongoing challenge too.
So it's a combination of difficulty, lack of specialists, and access issues. But there's hope. Technology is helping.
It is starting to make a difference. The sources mention projects using AI, specifically neural machine translation, to try and help translate Akkadian cuneiform. It's early days, but it could potentially speed up the initial processing of texts, maybe help decipher patterns.
Making the texts searchable digitally.
That's another huge step. Cuneiform signs have actually been included in the Unicode standard, the system computers use to represent characters from all languages.
So you can type cuneiform on a computer now.
Essentially, yes. Unicode means the signs have standard digital codes. This allows for creating online databases, searchable text corpora, collaborative digital editing tools. It's vital for making the material more accessible. The sources even note that the latest Unicode version, 16.0, added more ancient scripts like extended Egyptian hieroglyphs, so the effort continues.
That's cool. Bringing ancient scripts into the 21st century. And there was one last fascinating detail about a logo.
Ah, yes, the Liberty Fund logo. The sources point out that the cuneiform inscription they use is very specific. It contains the signs for the Sumerian word amagi,
And amagi means?
freedom or liberty. And this particular inscription from the city-state of Lagash around 2300 BC is believed to be the earliest known written appearance of that concept anywhere in the world.
Wow. So one of the first abstract ideas people felt the need to write down was freedom.
It's pretty powerful, isn't it? Right there in those ancient wedges. It shows writing wasn't just for tracking grain. It quickly became a tool for grappling with the big ideas, the aspirations that shape human societies. Writing gave those ideas permanence, a way to be shared and debated across time.
What an incredible arc. From clay tokens for counting sheep, devolving through pictographs and wedges, becoming this complex system that could capture laws, epics, math, astronomy, and even the concept of liberty.
Yeah, we've seen how writing wasn't just a passive recording tool. Its very development was tangled up with the rise of cities, empires, complex societies. It enabled that complexity. It shaped how knowledge was stored and transmitted, not just in Mesopotamia, but across the globe and through millennia.
It really makes you think, doesn't it? This invention we almost take for granted now.
Absolutely. And maybe the final thought to leave people with, circling back to those unread tablets, imagine what's still waiting in that 90%.
Yeah. What histories are we missing? What different perspectives on their world?
What scientific knowledge might be there? What other early philosophical ideas? Considering how much we've learned from the 10% we have read, the potential locked away in the rest is just immense. It's a reminder that exploring the past is far from over. Those clay tablets still have so much to tell us about where we came from.
Always more to learn. A perfect place to pause.